Okay, in the last video we talked about vector equations and we also touched on the concepts of linear combination and we looked at the parallelogram rule for addition, and now we're going to be talking about span. And this is a concept that builds on the idea that we talked about in the last video, namely linear combinations. So if v1 to vp, which are vectors, if these vectors are in Rn, then the set of all linear combinations of the vectors v1 to vp is denoted by the span with the curly brackets v1 to vp, and it's called the subset of Rn, spanned or generated by the vectors v1 to vp. That is to say that the span with the curly brackets of v1 to vp is the collection of all vectors that can be written in the form c1 v1, with v being, or the v variables being, the vectors and c being the weights, c1 v1 plus c2 v2 all the way to cp times vp. In the last video, we took the values for the weights and we put them into an augmented matrix. And in this video, talk about how you can do something similar with the vectors. And we can ask the question of whether a vector b is in the span v1 to vp. In other words, we can write x1 v1 plus x2 v2, and then we can sum all the way up to xp vp and write that equal to b. And that's the same as posing the question of whether the augmented matrix with the vectors in the augmented matrix, or the values of the vectors in the augmented matrix, and then B is the rightmost column, has a solution. Geometrically speaking, we can say that in R3, span V is the set of all scalars that are multiples of V, which is represented as a set of points on a line through V and 0. If we have two non-zero vectors, again in R3, and V is not a multiple of U, then span UV is the plane in R3 that contains UV and 0. In addition to the line through V and 0 in span V, span UV also contains the line through U and 0. As an example, say we have span A1, A2 as a plane through the origin in R3, and we want to know if B is in the plane. So let's say we've got A1 with three entries, 1, -2, and 3, A2, 5, -13, -3. And then we have that B is equal to -3, A, and 1. And as I've said before, this is the same as asking if x1 times A1 plus x2 times A2 is equal to B has a solution. To start, let's row reduce. So let's take the vectors A1 and A2 and let's put them into an augmented matrix with B as the rightmost column. And then we have row 1, 1, 5, -3, row 2, -2, -13, 8, row 3, 3, -3, 1, and then we go through a row reduction. And at the end of the row reduction, we have row 1, 1, 5, -3, row 2, 0, -3, 2, row 3, 0, 0, -2. And then from row 3, we see that the system is inconsistent, and x1 a1 plus x2 a2 equals b has no solution. So b is not in the span a1 to a2. To summarize, we said that we have the span a1, a2, which in R3 is going to be a plane through the origin. And we asked if b, the column vector b, we asked if it was to be in the plane. And through solving, or through doing row reduction and trying to solve this system of equations and seeing that the system is inconsistent with the augmented matrix containing A1, A2, and B, we said that that point corresponding to the column vector B is in fact not in the plane that is represented by span A1, A2.